Hello. In this video, we're just going to summarize how two linear systems can interact. And again, I want to stress that we're summarizing how two linear systems interact. If you're dealing with a quadratic linear system or two systems or a system that has nonlinear relationships, these interactions can change. But again, this unit focuses on systems of linear equations because we understand linear equations and it gives us a good starting point. But again, everything we're learning here can be applied to more advanced systems. So, two questions you want to ask yourself. How many ways can two lines interact? And what would happen algebraically if we solved the system? So, we have three different ways they could interact. And I'm just going to break this up into three. The first way is the lines could intersect at one point. So that is a case where if we were to draw a quick sketch here, we had two lines. I don't really care what they are, but what happens is those lines intersect at one point. So what that means in terms of algebra is that we will get x equals some value, let's say a, and y equals some value, let's say b. So therefore, we'll have x, y is equal to a, b. And we can say where a and b are an element of the real. Okay, actually let's write this down here, where a, b are an element of the real. And that means a and b can be any real number. Well, how else could these lines interact? The lines could be, the lines are parallel. And never touch. So, to get a picture here, if we draw a graph, if we have two lines and they're parallel and they never touch, in this case, there is no solution. There is no point of intersection. One thing I really want to stress here when you're talking about a system where the lines are parallel and they don't intersect is you have to talk about both the fact that they're parallel and that they have a different b value. Because two lines could be parallel and have an infinite number of points of intersection. So it's very important that you include the fact that the lines are parallel and they have a different y-intercept or different x-intercept to really distinguish that idea. Okay, so the idea now is what will we get algebraically? And if you are solving a system algebraically, you're going to end up with 0x equals a number, or you're going to end up with 0y equals a number. And if you ever get that, you know that there is no solution to the system. The third possibility are the lines are what we call coincident. And what this means is they are the same line. So in this case, this is a little harder to draw, but we can still try. In this case, let's draw one line in blue. So there's the one line, and we draw the other line. Let's draw it in red. It's right on top. Okay, and in this case, there are an infinite number of points of intersection. Algebraically, if you're working through a problem, what you're going to end up with in this case is you'll end up with 0x equals 0, or you're going to end up with 0y equals 0, which means any value of x would satisfy this, or any value of y would satisfy this. The last point I want to make before wrapping up this video is it's always good to be able to think of examples of these and come up with them on your own. So if we wanted to give really quickly an example where they intersect at one point, all you have to do is come up with any equation where they have a different slope and a different y-intercept. If we want an example where they're parallel and never touch, we need to write a system where they have the same slope but a different y-intercept. And finally, if we want to write an example where the lines are coincident, we just write the same line out. And remember, I could multiply both sides, so I could end up here, this line is the same as well, because I've multiplied both sides by 2. I hope that video helped. Good luck playing with systems of equations.